Okay, so previously we had two resistors. Very troublesome if we want to change the resistance. We got to take out resistance, put back in a new resistor and so on. So the setup you will see and do in school is this. You will have one battery connected to a wire like that, which is often attached to a ruler. You will definitely do this for sure. And you not just do once, you do quite a number of times. Okay, and it's a 100 cm wire. So remember, the resistance of a wire varies proportionally with the length. So everybody, I put one voltmeter here, okay, and I have something called a jockey. What is a jockey, or what they call a slider or contact? A jockey is not the person that riding on a horse. Okay, the jockey in the lab is like like a pen. It really looks like a pen, but it's a metal tip. So you're supposed to press down on the wire. Okay, you will know when you get there. Now everybody smart, intelligent people. This is 100 cm long. This is 10 volts. Shivani, smart, intelligent. Where should you think I should press my jockey down in order to get 5 volts? In the middle. How many cm?
50.
Correct. Right? So when you press this down at 50 cm mark, what are you doing? You are dividing the resistor into half. First half, second half. Right? So as if to say, oh, this 5 ohm, this 5 ohm, right? So what you say is absolutely correct. You can guess it out one. So if let's say Seth, I want 2 volts. You tell me where to put.
Put at 20 cm.
Put 20. Raghu, I want 8 volts. Put where? 80 cm. Right? So you can guess. Then you're thinking, okay, I want to know what's the theory behind it. How come it can work like that? One, because it's still back to proportional. Right?
Isn't that just the wire?
Yeah, it's the wire. You are moving, you are taking this and dividing the resistance of this wire into 2 parts. This part and the second part.
As in, like, take the arrow thing as a wire.
Arrow thing.
That thing.
This thing.
Yeah.
This thing is the jockey.
Just take it as a wire.
No, don't take it as a wire. This is the wire. This is the jockey. Okay, this is the wire which has a resistance which you want to vary the resistance of. Okay, don't confuse with this. This is just a wire with a jockey. It's just to clip onto this only. That's all. Okay. Okay. So, Kaisen,
Yeah.
put my jockey here. How many volts? Over here.
5. That.
10. 10 volts. And then the most confusing one, which people often get wrong. Put here. What? I put at 0 cm. How many volts? Put at B, 10. Put at 0, 10 also, man. 0. Why 0? This point is at the same potential as the jockey, right? If they are both at the same potential, the potential difference is? That means the voltage is? Correct. Okay? So when you put here, next time when you set up this in a lab, you try out for yourself. You put at 0 cm, you're going to get 0 volts. Okay? Right? So that is the idea behind it. Okay, now, how to convince you in detail the theory?
I started a fire also.
Yeah.
I burnt my circuit in the
Yeah, my
lab.
friend also
You
burned.
short circuit lah. The thing.
No, they
got
just
like
all
a smoke, you know.
connected.
Fill this up. When the slider is moved towards B, it's going towards B. Fill this up. The resistance across AC, what?
Larger.
Down, increases. Fill it up. Where's the resistance across CB will? So AC is increasing. Then CB is
Smaller.
decreasing. Okay? Now this one, be very careful. The current, would the current change not?
No.
At all? Why not? Because this in effect is still a series circuit, right? This is still a series circuit. So you don't, people will say, oh no, okay, the current gets smaller, or no, it's getting bigger. Very confused. Look at the way the current flow. It comes like that, comes like that. It's still going to go through here and back. It never goes through the voltmeter. So even though you are dividing the resistance into whatever proportion you want, the current is still the same. Okay? So the current remains the same even as slider going from A to B, right? Okay. Hence, VCB, okay, this is again very confusing, got so many terms here. As you are moving the slider towards C, as you are moving the slider towards B rather, VCB, this voltage here will what? Increase or decrease? Decrease. Why? Because I told you memorize this. This one resistance here is getting smaller. So whatever voltage there's across here to here will also decrease. Then if this one's resistance is increasing, this voltage end result will also be increasing. Correct. So this is increasing. Okay. So you just now I already tell you, ask you make all the correct guesses. Oh, here 5 volt, here 8 volt, very easy. The explanation is this. Alright? Then what is the relationship between all this? I think you know. V out, proportional relationship. V out, where is V out? Okay, got to look at where is V out. So many things all over the place. V out is over here. So V out is here. That means this R is R. Which one? Which R? Be very careful lah. Which R? R? This one, right? AC, right? AC, right? Yeah, AC. AC. Then the bottom one is AC plus CB. Or you want to say AB also can. Yes. And then there's one more thing you must times. Don't forget. What is it? Obviously, the V total. Okay? So there's a relationship. Okay. Then now, since we are talking about wires which have length, and L is proportional to R, we can simply replace everything by saying, let's just call it V1. Very troublesome, V out, all this. Very, very confusing. Okay? Now, replace by length. This one will be what? L. On top will be L. If this is V1, I measure this length, L1, this will be L1. Over L1 plus L2. Okay? So, that is your formula, your proportion formula you are most likely going to use most often. Okay? This one, very useful lah. Okay? Very, very useful. Right. So, so what happens if I really put a buzzer here? Okay? If I put a buzzer here or a lamp here and I keep moving this jockey or slider higher and higher, this lamp will become brighter and brighter. Right? Then if I want totally no brightness at all, take this jockey, put it where? A. Because the potential will be, the voltage is 0. Okay? So that's how you can use it as a control. Alright? Okay, come, go through very fast. Okay, first one, voltmeter reading at 0 cm, answer is? 0 volts. At 100 cm? 10 V. Right? Okay? Now this one, some of you want to do by explanation also can lah. But if let's say you want to do by calculation, where must the jockey be placed to get 5 volts? All of you know it's 50 cm. How do I do that? Okay lor, like that lor. Write out a formula like this. Okay, so I want 5. That means I'm looking for L1. What's my total length of my wire is 100. So what's the total voltage is 10. So you will simply show then that this will come out to be 50 cm. Okay, as simple as that. Alright, so you can just show simple working. If you want to explain also can, you can say I put it at the 50 cm mark, because at the 50 cm mark it divides the potential of the total wire by 2 times. So the voltage across for V would then be 5 volts. Okay, so you also can. You want to explain like that also can. Huh? So then this one again, you just show working. As I say shows, write down the formula. Okay, your teacher appreciate that that you write this down and then you calculate, rather than I just throw in some numbers and how you get. I also don't know how you get. Okay, so very easy to figure this out. All right. Okay, then from here onwards, this is the theory. So from here onwards is a whole variety of questions, and it can get quite confusing. And later you will see, you get harder and harder. Right? That's why I say your basic must be right. Okay, you don't get a basic right, everything very difficult. Okay, so this one, you can try this one now. Okay, so you see the setup, you see, oh, 2 resistors like that. That means I can use the proportion formula, okay, if I want to. So this one can vary from 0 ohms to 100 ohms. Alright, this is a variable resistor. What's the maximum and minimum voltages? So if I want this to be a minimum voltage, this one resistance should be maximum. Make this very high, right? Then this voltage here will be very large, then this voltage here will be very small, right? So can you see an advantage when you know the outcome? Yes, you can. Now you don't know the outcome also can. You still can just RIV the thing, or you can go and work it out also can. But knowing something, the end result is definitely going to be useful. Okay, so you try. So when you want you want maximum output voltage. Okay, let's do this first. When you want maximum output voltage, okay, what do I do?
Make it is resistance.
R1 make it what?
0.
0. Okay, so you put this on 0. Okay, 0 ohms. Right? Then you are supposed to calculate V out. Again, V out. Right? V out. The formula for V out is here. Just be very careful. R1 over R1 plus R2, or R2 over R1. Which one? R2 over
R1 plus R2.
R1 plus R2
V total.
times V total. Okay, so R2 is how much?
R2
Fixed, right?
is
50. Total resistance how much? Over 50. So this one is
9.
9, right? So it comes out 9 volts. Okay. So some people again might say it is also obvious one, right? If this resistance 0, here 9, then the whole thing must be 9 Yes, correct. Okay, but if you want to show some form of working, this is your some form of working. So you are using the proportional formula over here. Now, what if I don't know this formula? Last time I never even teach the students this formula. Also can do. Why? How they do it? They use I equal V over R. Okay, so you see how to use. Let's try I equal V over R, see whether can get the same thing. So I total equals to V over R total, right? So this will be 9 divided by, what's the total resistance when this one is 0? This is 50, right? So this 9 over 50 amperes. Correct? Okay, So now I want V out. So V out equals to IR again. So I is how much? 9 over 50 times, what's this? 50, right? Also get back 9 volts. So you see, knowing this is great, okay? It makes your life to calculate things faster. but you can also always do by what you know now, the fundamentals, right? Both works. Okay? Okay, so I done the half for you, now you do the other half. What happens when you want minimum output? Okay, so what happens? Minimum output, you do this yourself. So R1 now has to be very, very large, right? So how large can you make it? Okay, I have to make it 100. Okay, you can do by two ways. Show yourself that you know how to do it by two ways. Okay, so use this formula, you will get 3 volts. Okay, use this way, also possible, right? So very, very good and useful. Okay, so next page. Okay, you look at this question over here. Okay, this one over here, this question was my school question last time we won a prelim exam. Okay, where they were asked to describe how this lamp here changes, okay, in brightness. Alright, not only that, okay, ask 3 things. Ammeter reading, how it changes, voltmeter reading, how it changes, and the brightness of the lamp, how it changes. Alright, as this jockey or slider is moved from X to Y. Okay, very badly done. Because you say, so difficult, man. Because the way the answer is totally all over the place. Here, I make your life easier. I ask you to fill in the blanks. Okay, so when you go and explain this, you got to first say, Kaisen, keep the phone. S is at X. Then when S is at X, you answer from there first. First paragraph is at X. Then the next one, slowly increase. Then the third paragraph when it's at Y. Okay? End result, you all should know already, unless you've not been listening to me. As long as this slider is you're moving this slider from X to Y, the brightness of the lamp will be increasing, right? The voltage across here will increase, right? Okay, so you should know that. Okay, so now because I explained it, okay, give you 2 minutes. Okay, so when you put the jockey here, what happens?
Short circuit.
Short circuit. Yihui, here, what's the voltage?
Oh, 0.
What's the current? If the voltage 0, the current will be?
0?
Yeah lah, then say lah.
I say already.
No, never hear you. Okay, Rago, carry on. When S moves from X to Y, the resistance from X to S. So S is here. S is moving further and further. So Rago, resistance is?
Higher.
Okay, higher, increasing lah. Use the word increasing. Okay, set. The voltmeter reading V is?
Increasing.
Yes, good. Kaisen, the brightness of lamp is? The ammeter, okay, it's increasing lah because V got R, right? Okay, then Edison, at Y, the voltmeter reading is?
Higher.
Okay, let's give a more precise term. It's at Y already. It is at the maximum. Then the brightness of the lamp is? Maximum. Then the ammeter reading is? Maximum as well. Okay? So in the end, if I give you fill in the blank, it should be quite straightforward. Right, so this again helps you understand what is happening over here. What are you doing over here? Alright, okay, then after that, we sidetrack for a while away from all this potential meter. Okay, so by the way, what is a potential meter? A potential meter is something like that. This is a setup. This is a basic setup circuit of potential meter, like this. Okay, it's not a meter okay, it's actually a circuit setup. Alright? Okay, let's go on to draw some graphs, talk about some graphs. Non-ohmic conductors. Okay, when filament lamp, this one I already told you before, but I gotta keep saying because they love to ask about graphs. Okay, when the temperature rises in a filament lamp, the resistance will also increase. How will the graph look like? Look at the graph axis. Here is I, here is V. So be very careful. So what kind of are you going to get? Like that or like that? A or B? Which one?
No, B. Few.
B.
Like that. Why?
Few accident.
Why? If it's V against I, the gradient gives you resistance, right? So the gradient must be increasing, so the resistance increasing, it will look like that. Okay? But if it's I against V is the other way around, then your graph will look like this. Okay, so be careful, watch out for the axis.
Non-ohmic is like stuff that cannot be affected by physical. Like,
That means V is proportional to I. That means R always the same one.
what's non-ohmic conductivity?
Non-ohmic, ohmic means V is proportional to I. So non-ohmic means not proportional. That means the resistance will change.
Physical, yeah.
Ah.
Like temperature.
Yeah, like for example temperature. So for example, you will say a thermistor definitely non-ohmic one, right? Because
so non-ohmic is like not affected by temperature.
Non-ohmic is a factor.
Or non-ohmic is affected.
okay, so it's one factor. When the temperature rises, the resistance the opposite decreases. Alright, so the gradient of the IV graph increases. Okay, so it looks like that. Why? How to explain this? Okay, if you are saying the voltage of thermistor increasing, what happened? The current through the thermistor increases as well. Once there's more current passing through, you're going to get more heat produced. Right? More heat produced means what? The temperature will rise. And then when the temperature rises, the resistance of the thermistor decreases. Okay? So what happens? As the resistance of thermistor decreases, so current increases very much more. So you see, wow, this one increase on current so much, exponential suddenly. Alright? This is the way to explain. They ever ask them to explain like that. Why is there such a sudden increase in current? Nobody, how you explain that? Okay, so this is the way they explain. So the voltage increase, current increase, more heat produced, hotter, right? Higher temperature, in this case, because it's the thermistor, resistance will drop. Then as we drop, the current will increase even more. Okay, so that's how you can explain this.
Like she shout. Yeah.
Semiconductor diode, look at the graph. This part, again, there's a very
Just ignore me.
high increase in current for a certain voltage. Whereas this part, when you draw this part is as good as near zero. Right? Why? Because you reverse the potential. You reverse the direction of the diode. So when it goes the other way, the current can hardly flow. Okay, so this is as good as you can draw it on the x-axis, is zero. Okay, so that is your LED, what it looks like. Alright. If it's a normal resistor, it will just look like that, one straight line like that. IV graph, one straight line. Alright, it works both ways. You can change the voltage, the battery the other direction, current also still flow. It's not going to be affected. But for LED or semiconductor diode, you change the direction. Okay, let's say you change it this way, no current is going to flow. That's why this part is zero. Okay? Yes. Yawn of approval. How many more points is that? 50 already. That's another, now 55. Okay lah, the two of you, 57, 55.
You should add a limit to push ups.
Oh yes.